try to do better with spacing in the future as I do more videos, but hopefully you can follow the work. Here is another problem that we are going to work using molarity in stoichiometry. So the problem reads, calcium carbonate reacts with hydrogen chloride, hydrochloric acid, to make calcium chloride water and carbon dioxide. How many milliliters of a 0.22 molar solution of calcium carbonate are needed to react completely with 25 milliliters of a 0.5 molar solution of hydrochloric acid? So the first thing we're going to do, step one, let me go back to pink. Step one is write the balanced reaction. Step two is follow the diagram. Okay, maybe we need to identify what is substance A and what is substance B, okay, because if you go up to this diagram, we have a solution A and a solution B. So identify those, but we're going to follow that diagram pretty closely on this problem. So let's write out our balanced chemical reaction. It says calcium carbonate. Calcium carbonate is calcium, which is a +2 charge. Carbonate is CO3 with a -2 charge, so just one cation, one anion, or polyatomic ion there. So that's calcium carbonate. It says reacts with hydrochloric acid, hydrogen chloride, HCl. And it makes calcium chloride. We'll need 2 chloride anions there because calcium is a +2 charge. And water and carbon dioxide. Okay, so there's our balanced chemical reaction. Well, there's our chemical reaction. We need to balance it. How do we balance this? So we've got 1 calcium, 1 calcium, 1 chlorine atom, 2 chlorine or chlorides. So we'll need to balance our chlorides. We've got 2 hydrogens, 1 hydrogen, 1 carbon, 3 oxygens. So if I put a 2 right here in front of HCl, I think that fixes everything. 1 calcium, 1 calcium, 1 carbon, 3 oxygens on the reactant side. Looks like we got 3 on the product side. 2 hydrogens and 2. Okay, we're good. So now we do have a balanced chemical reaction. So first we wrote our balanced reaction. Now step 2. Let's identify what is substance A, what is substance B. Well, we are given a volume of hydrochloric acid, and I'm going to circle that in bright green right here. 25 milliliters, and there's our molarity of a solution of HCl. Okay, so because we're given the volume of hydrochloric acid, this is substance A. Okay, so substance A is HCl, and substance B is the one we're trying to find. Okay, so it says how many milliliters for calcium carbonate. So substance A is HCl, substance B is calcium carbonate. So that is going to help us follow the diagram. So the diagram says you start with volume of solution A, which is HCl. So we're going to start with the volume. I'm going to start over here on the left side, 25 milliliters HCl. And according to the diagram, whoa, what happened? That looks really blurred out. I don't know what happened. Our diagram isn't very visible. So, well, what the diagram says is that we're going to go from volume to moles using molarity. But if you remember, molarity is moles per liter, not moles per milliliter. So we need to convert from milliliters of HCl to liters of HCl. So we're going to go 1,000 milliliters per 1 liter, so that units of milliliters cancels out, and now we have liters. Now we are going to use the molarity of HCl, which is in the last sentence here. It's 0.5 molar, which, if I write this out, 0.5 molar HCl is equal to 0.5 moles per 1 liter of HCl. So this is actually what I'm going to plug in, and I want liters to cancel out. I have liters on top over here, so I'm going to say for every 1 liter there's 0.5 moles HCl. So I just use my molarity as a conversion factor to convert from units of liters to units of moles of my substance here. Now, is it still blurry? No, not anymore. Okay, so now I have moles of HCl, and I want to go from moles of HCl to moles of calcium carbonate in this case. So we're just following this step again right here. We'll do that with a, too far, mole to mole ratio. Okay, so if you look at our mole to mole ratio, our coefficients for calcium carbonate and HCl, which are our two reactants, it's a 2 to 1. We want to cancel out moles of HCl, so for every 2 moles HCl, we get 1 mole calcium carbonate. So I just plugged in my mole to mole ratio, moles of HCl cancel out, and I have converted to moles of calcium carbonate. And then the problem also, if you look up the second sentence, says how many milliliters, that's what we're looking for, the volume, of a 0.22 molar solution. Okay, so here is the molarity of calcium carbonate. So the last step in the diagram is once we have moles of B, which in this case is calcium carbonate, we're going to go to volume of B using the molarity of calcium carbonate. We want moles of calcium carbonate to cancel. So if we kind of come down here, I have 1 mole calcium carbonate. Oops. I have 1 mole of calcium carbonate on top, and we're just going to move forward. The molarity of calcium carbonate says that for every 0.22 moles, we get 1 liter of calcium carbonate. Then lastly, it says how many milliliters. So we're going to go from liters to milliliters. So for every 1 liter, we get 1,000 milliliters. Okay, so this right here that I plugged in, this was the molarity, the 0.22 molar, okay, which again for calcium, I should say calcium carbonate, which means 0.22 moles of calcium carbonate for every 1 liter. Okay, so just to make sure you know why I plugged those numbers in the way I did, we wanted moles of calcium carbonate to cancel, and we were left with liters. Then we go from liters to milliliters, which is what our question is asking for. So let's calculate this now. 25 divided by 1,000 times 0.5 divided by 2 divided by 0.22 times 1,000, and you should get 28.41 milliliters of calcium carbonate. And that is our answer for this problem. So now we've looked at 2 problems, one with the stomach acid magnesium hydroxide tablet. We used molarity as a conversion factor there. And then another problem where we had to use molarity twice for 2 different substances in stoichiometry. Okay, so we're going to move on. I can certainly post more problems if you want to practice this. These types of problems for exam 3 are where they're going to be some of the more challenging problems. So I would definitely encourage you to practice using molarity in stoichiometry and using molarity as a conversion factor.